All right, let's dive into something really fascinating today. We're going to be talking about multimodal large language models.
MLLMs.
Yeah, MLLMs.
Yeah.
But not just any MLLMs. These are ones that can actually reason, think like we do, not just spit out an answer.
It is a huge leap forward, yeah. We're moving beyond just getting the right answer. We're trying to understand the how, the why, the thought process behind the AI.
It's like, we've all been there. The AI gives you the right answer. And you're like, but how?
Right.
Like, did it really get it? Or was that just some sort of lucky guess?
Yeah, it's like that Feynman quote, right? What I cannot create, I do not understand.
Exactly.
And this is where this new method comes in.
Okay.
It's called Collective Monte Carlo Tree Search, or COMCTS. And it's all about training a powerful MLLM called Mulberry to reason in a more step-by-step, transparent way.
Okay, QMCTS.
Yeah.
Now, I'm intrigued. I know it was inspired by how AlphaGo learned to just dominate the game of Go, which is pretty impressive in and of itself.
Yeah.
But how does it actually work?
So imagine a team of MLLMs all working together to solve a problem, each bringing their own strengths and perspectives. That's essentially what COMCTS does. It uses the power of multiple models to explore a wider range of possibilities.
So instead of just one AI, try to go it alone, it's like a whole team, like a brain trust.
Right.
That's pretty cool.
It is. It is. And this collective learning, it happens through 4 iterative steps. So first, we have expansion. Think of it like, brainstorming.
Right.
Each MLLM suggests possible next steps to solve the problem.
So it's more dynamic.
Right.
It's more collaborative than the traditional way of thinking about it.
Precisely. Now, once we have all these potential paths, the next step is simulation and error positioning.
Ooh.
So now the team really flexes its analytical muscles. They simulate the outcomes of each suggested step and try to identify which paths are likely to lead to errors.
So it's like they're almost peer reviewing each other's work.
Exactly.
They're trying to find the holes.
Yeah. And sometimes it's easier for one MLLM to spot another's mistake than its own.
Oh, interesting.
It's like having a fresh pair of eyes on your project.
Yeah. Okay.
Then comes backpropagation, where they adjust the scores of each reasoning step based on the simulation results.
Okay.
So they're basically saying, okay, this path looks promising, let's give it a higher score. Or this one's leading us down a dead end, let's lower its score.
So it's like they're constantly refining, they're learning from the simulations, and they're trying to get closer and closer to the actual best solution.
Yes. And then finally, in the selection stage, they pick the most promising next step based on those scores, and the whole process repeats. So it's this iterative cycle until they've built this robust solution tree step by step.
So it's expansion, simulation, evaluation, selection, and it just keeps going until it gets to the right answer.
Exactly.
It's not only effective, it's efficient too.
Right, exactly.
It's saying that this joint simulation and error positioning actually allows them to skip steps. So it saves time, it saves computing power.
Exactly. It's remarkable how they optimize the search process. They don't have to go through every single step. They can identify the last correct step in a branch and just continue searching from there.
Okay.
So it makes the process much faster.
Okay, now this is something that really caught my eye, this idea of reflective reasoning.
Yeah.
That AI can actually learn from its mistakes. It almost seems counterintuitive.
It does.
I mean, isn't that a very human quality?
It is. You're right. It is very human. And that's what makes COMCTS so innovative, right? It's not just about finding the right path. It's about learning from the wrong ones.
So it's like turning those failures into fuel for the next success.
Exactly. As the MLLMs explore all these different paths, they inevitably encounter errors. But those errors, those become really valuable learning opportunities.
That's really incredible. So, okay, let's talk about this massive Mulberry 260K data set, 260,000 multimodal questions.
That's right.
Text and images.
Text and images covering math, science.
Medical imaging. I mean, and that's a lot.
It's a lot of data, and all those questions are annotated with these detailed reasoning trees that were generated using COMCTS.
Wow.
So it's like a gold mine for training MLLMs to reason step by step.
Okay. Well, I'm looking at some of the stats here, and I'm seeing that the average number of reasoning steps is 7.5.
Yeah.
But it varies, right? Chart-based questions, 6.8. Geometry problems, 8.9.
Yeah.
how does the model know how many steps it needs to get there?
So the model actually learns to adapt its reasoning process based on the complexity of the problem. Just like you might quickly solve a simple Sudoku puzzle,
Right.
but then take much longer for a more challenging one.
Right, makes sense.
That ability to kind of adjust its approach is a key indicator of its growing intelligence, we could say.
So, okay, we have this massive data set of questions and reasoning trees. How do we actually use that to train the Mulberry models? How do we get the AI to internalize this whole step-by-step reasoning process?
So that's where this idea of collective supervised fine-tuning comes in. We use two main types of training. One is called LCO-SFT, which focuses on learning from the correct reasoning paths.
Okay.
And the other one is LCO-SFT-RE, which incorporates those reflective learning moments, allowing the model to learn from its mistakes.
So it's like having a teacher that doesn't just show you the right way, but also shows you why the wrong way was wrong.
Exactly. And these two approaches work together to ensure that the Mulberry model doesn't just find the right answer, but understands the reasoning behind it.
So what were the results? I mean, did it work?
Yeah, the results were very impressive. Not only did the Mulberry models outperform baseline models, but they were even competitive with those powerful closed-source models on various benchmarks. So they're not just holding their own. They're exceeding expectations for a model that's designed to be more transparent and explainable. And to confirm that both the collective learning and the reflective reasoning components were essential to this success.
Yeah.
They did what are called ablation studies.
Okay, what's that?
So they removed each component to see how it affected performance. And when they did that, they found that the performance dropped significantly. So it highlights the importance of both of these elements. It really validates the power of this collaborative and reflective approach to AI training.
So it's not just about making AI smarter, it's about making it smarter in a way that we can understand.
Exactly.
In a way that we can trust.
Right.
It's like a whole paradigm shift, moving away from that black box and going towards transparency.
Absolutely. It's a shift with profound implications for how we develop and use AI.
Well, there's a lot to unpack there. I mean, wow.
Yeah.
We're just getting started.
Yeah, we are. One of the most fascinating things about this whole thing, this whole research, is how it addresses this fundamental challenge in AI, the black box problem. For years, we've been building these AI systems that can do all this stuff,
Right.
solve problems, but often we don't really understand how they're getting there.
It's like having a brilliant chef who can whip up these incredible dishes, but they can't tell you the recipe.
Yeah.
You're just like, well, it tastes great, but how did you do that?
Exactly. And that lack of transparency, that can be a real barrier to trust.
Right.
Especially when we're talking about AI being used in critical areas like healthcare, finance, self-driving cars. Would you trust a medical diagnosis
No way.
from an AI if you didn't understand the reasoning behind it?
We need the why.
Yeah.
Especially when the stakes are so high.
Exactly. And that's where CTS comes in. By forcing the MLLM to break down its reasoning into these discrete steps, we're essentially opening up the black box. It's like giving the AI a voice, allowing it to articulate its thought process so we can follow along, so we can understand.
So it's like that chef not only cooking the meal, but then showing you, okay, here's how I did it.
Exactly.
Step by step, here are the ingredients, here's what I did. Not only do you appreciate it more,
right,
but now you can do it yourself.
Exactly. Transparency, it's not just crucial for building trust, but it's also essential for debugging, improving these models.
Right, if you can see where it's going wrong.
Exactly. If we can see where the AI might be going wrong, we can correct those errors. We can make the system more robust.
Okay, so great in theory, but what about in practice? What are the real-world applications here?
Well, imagine an AI tutor.
Okay.
That could not only give you the right answer to a math problem, but also break it down step by step. Guide the student through the process.
Okay.
It's like having a personalized tutor who can adapt to your own learning style.
It'd be a game changer for education.
Yeah.
Especially for those subjects that a lot of people have trouble with.
Totally. And it goes way beyond education. Think about medical diagnosis. An AI powered by CTS could analyze medical images, pinpoint areas of concern, and then provide a detailed explanation of its reasoning, supporting its conclusions with evidence from the images.
So instead of just saying there's a 90% chance of a tumor, It can actually show, here's what I'm looking at.
Exactly.
Here's why I think that.
It could even help to democratize access to medical expertise.
Okay.
Imagine a world where even in remote areas, people can benefit from these AI-powered tools that can provide accurate and explainable diagnoses.
Wow.
So we're not just making things more efficient, we're talking about improving lives.
Right. Using it for good.
Exactly. And these are just a few examples. The possibilities are endless. We could see it revolutionize fields like scientific research,
Oh, yeah.
engineering, finance. It's really about enhancing human capabilities, helping us to think better, solve problems faster, make more informed decisions.
It's almost like AI is not just a tool, but a partner.
Yeah, exactly. That's the exciting potential here.
Okay.
But of course, as with any new technology this powerful, we have to address the potential risks.
That's a really good point. We can't just focus on all the good stuff.
We can't.
What about the possible downsides?
Right. For example, what if someone uses this to create systems that can generate convincing but fabricated arguments?
It's like weaponizing logic.
It is. And that's a valid concern. As AI becomes more sophisticated, we have to develop ethical frameworks, we need guidelines, we have to make sure these tools are being used responsibly.
It's like we're at a crossroads.
We
It's incredible technology that could do so much good.
Right.
But we have to make sure that we use it wisely.
And that responsibility, it doesn't just lie with the scientists, the engineers.
Right.
It's with policymakers, with ethicists, with the public. We all have to be part of the conversation.
So we've talked about the philosophy, we've talked about the applications,
Yeah,
we talked about the risks.
we have.
But there are challenges. I mean, what are some of the challenges?
Yeah.
And how can we maybe use what we've learned from this research to kind of guide us?
Well, one of the biggest concerns is the potential for unintended consequences.
Yeah.
We need to be very mindful that these AI systems, even those designed with good intentions, could have unforeseen negative impacts.
It's like that classic sci-fi trope, right?
Right.
The AI that gets too smart and turns against its creator.
Exactly.
But even without going that far, I mean, there's a real risk that it could be used to harm people
Right.
or exploit them, especially if we're not thinking about the ethics.
Exactly. That's why it's so important to have these conversations now.
Right.
While the technology is still relatively young, we need to anticipate these problems and we need to develop safeguards.
It's like building a house, right? You don't just start putting up walls. You have to have that strong foundation.
Exactly. And that foundation, that includes the technical safeguards, but it also includes ethical principles,
Okay.
societal values that will guide the development and use of this.
So it's not just making sure it works.
Right.
It's making sure it works for good.
Absolutely. Now, another concern that comes up is explainability.
Uh-huh.
Even if we mitigate unintended consequences, even if we're sure the AI is making decisions that are aligned with our values, how do we know that it's making those decisions for the right reasons?
It's one thing for it to make an accurate prediction, but it's a whole other thing to understand why.
Exactly.
I mean, without that, how can you really trust it?
And that's where that step-by-step reasoning comes in. If we can see how the AI arrived at its conclusion,
Yeah.
we can better understand its logic, we can assess whether it's making sound judgments.
So it's not just about the what. It's about the how. It's about the why.
Exactly. And the research on Mulberry shows that Common CTS can be a really powerful tool for achieving this level of explainability. By breaking it down, we can trace the AI's thought process,
Okay.
follow its logic from the initial input all the way to the output.
So it's like you can actually peek inside and see how it's thinking.
Exactly. And that level of transparency is really essential, not just for the user for building trust, but also for the developers, the researchers who are working on this. If we can understand how it's making decisions, we can identify where it might be going wrong and we can fix it.
So it's like having a map, basically,
Right.
of its reasoning.
Exactly.
But doesn't that also come with some risks, though? I mean, if it's that transparent,
It does.
couldn't it be manipulated?
That's a valid concern. If we make the reasoning process too transparent, then it's possible that malicious actors could exploit that
Right.
and try to manipulate the AI's decisions.
Right. So it's tricky.
It is. It's this delicate balance. We need enough transparency so that we understand and trust it, but we also have to protect it from those who would try to take advantage of that.
All right, well, kind of switching gears here a little bit. What about the research process itself? I mean, what impressed you about how the researchers approached this?
Well, their commitment to open science was really commendable. They documented everything, they shared their code, they made everything available to other researchers.
Well, that's really cool. I mean, it's not always like that.
No, it's no.
especially in a field that can be so competitive
It can be.
and secretive.
Yeah.
So by being open, they're really helping to advance research.
Exactly. It fosters collaboration, and it makes sure that these benefits, the benefits of AI are shared. I mean, everybody wins.
Okay, so speaking of advancing knowledge, what are some of the things that other researchers should learn from this research?
Well, one of the biggest takeaways is the power of collective intelligence. The researchers showed that by combining the strengths of multiple AI models, we can create systems capable of much more complex and nuanced reasoning.
It's like two heads are better than one.
Right, but in this case, it's more like multiple models.
Yeah.
And it's not just about having more, it's about having models that are different,
Yeah.
that bring different perspectives, different strengths.
Oh, that's interesting.
And that diversity, that's really key to unlocking that collective intelligence.
Well, it's a cool concept, and it could apply to more than just AI.
Absolutely,
I
absolutely.
mean, imagine applying that to human teams, to companies.
Totally.
So what about the future? Where do you think this research is going?
I think we're just at the beginning.
Yeah.
As researchers refine COMM-CTS and they develop even more sophisticated MLLMs, I think we can expect some big advancements.
Okay.
AI might be able to not only diagnose diseases, but also discover new treatments.
Wow.
AI might be able to not just analyze financial data,
Yeah.
but predict market trends.
So it's really exciting to think that it can become a real partner.
It is. It is. But as we go further,
Yeah.
we have to do it responsibly. We
Right.
have to make sure it benefits everybody.
It's a big challenge,
It is. It is.
but it's also really inspiring, right?
It is.
And I'm sure all the bright minds out there working on this will keep pushing the boundaries.
They will.
Well, let's take a second to think about what we've learned.
Yeah.
And let's consider the implications.
Absolutely.
It's just mind-blowing to think about it, that we're creating AI that can learn, that can reason in ways that we used to think were only human.
Yeah.
It really makes you wonder,
It does.
what is intelligence?
Yeah, it's a deep question. As AI keeps evolving,
Yeah.
it's really blurring those lines. What does it mean to be human?
Right.
What does it mean to be intelligent?
It's almost like AI is holding up a mirror
Yeah.
to our own minds
Yeah.
and maybe helping us understand ourselves better.
It is. By studying how AI learns, how it reasons, we get these insights into our own brain.
Right. And as we develop these systems to be more transparent, more explainable,
Yeah.
it becomes easier for people to understand them
Exactly.
and to trust them.
Transparency is key to public acceptance. When people can see how it works, they're more likely to be okay with it being used in their lives.
But, with transparency comes challenges too.
Mhm.
We talked about that.
We did.
Balancing that need to make it understandable,
Right.
but also protecting it from misuse.
It's a tightrope walk.
It is.
It's a tough one.
Well, we covered a lot,
We did.
the technical innovations, the potential. All right, let's dive into something really fascinating today. We're going to be talking about multimodal large language models.
MLMLMs.
Yeah, MLMs, but not just any MLMs. These are ones that can actually,
Oh, hey, I think our listeners got something to say.
Can we make a horizontal comparison with this study?
okay, that's a great question. So you're asking how we can compare this research to other similar studies, right?
Yeah, it's about putting this work into context and seeing where it fits within the broader field.
Exactly. And there are a couple of different angles to consider here.
What's fascinating is a lot of existing models struggle with that step-by-step reasoning, and that's where this new method really shines.
Yeah, so other models might be able to give you an answer, but they don't really show you how they got there.
Right. It's like, did it really get it, or was that just some sort of lucky guess?
Exactly.
And that's where this new method, collective Monte Carlo tree search, or COMM-CTS, comes in as a way to improve on that.
Okay, COMM-CTS. Now I'm intrigued. I know it was inspired by how AlphaGo learned to just dominate the game of Go, which is pretty impressive in and of itself.
Yeah?
But how does it actually work?
So imagine a team of MLLMs.
Okay.
all working together to solve a problem, each bringing their own strengths and perspectives. That's essentially what CoMCTS does. It uses the power of multiple models
Okay.
to explore a wider range of possibilities.
So instead of just like one AI, trying to go it alone, it's like a whole team, like a brain trust.
Right.
That's pretty cool.
It is. It is. And this collective learning, it happens through 4 iterative steps. So first we have expansion. Think of it like, brainstorming.
Okay.
Each MLLM suggests possible next steps to solve the problem.
So it's more dynamic.
Right.
It's more of a collaborative than like the traditional way of thinking about it.
Precisely.